Hey, this is Ralph. Welcome to a new tutorial on creating a VR game from scratch. This will be a whole tutorial series on creating a VR game in Unity 3D. And I also now created a GitHub account and a project where you can follow along, download the project, or you can also try to create the project from scratch on yourself. This is the second video. If you have not watched the last video, I do recommend you to check that out. There is a link in the description, and today we are going to actually revisit the last video. I will provide some more explanations because last time I felt that some people didn't understand the why behind some of the steps I did, and yeah, we will also do some improvement to the project because there are still some things that don't work as they should. And yeah, let's get right started. The first thing we did last time is go into File, Build Settings, Player Settings, and then under XR Settings we enabled VR supported. And what that does is tell the Unity application that we want to create a virtual reality app. And also under the virtual reality SDKs, we selected the OpenVR SDK and deleted the Oculus SDK. Okay, let's first talk a bit about what an SDK is. An SDK means Software Development Kit, and it is a library you can download from a manufacturer's website usually. For example, it could be Oculus or Valve, and you can use this kind of library to directly talk to the HMD or the hardware the manufacturer has provided. And it is an easy way to program applications for specific platforms. Right now there are two major SDKs which are used for the PC virtual reality applications, which is the Oculus SDK and the OpenVR or SteamVR SDK. The OpenVR and SteamVR is basically the same SDK, or they are just different names. The SDK is called OpenVR and the runtime is called the SteamVR runtime. It is a bit confusing that there's two names for essentially one thing, but in general you could say it's the same thing. So if we talk about OpenVR, it's also the SteamVR SDK. So the first step now would be to download the native SDKs from the manufacturer website. So let's say I want to create an application for the HTC Vive. I would go to the website and download the SteamVR SDK. Or let's say I want to create an application for Oculus. I download the Oculus SDK. The problem right now is with that is if we want to create an application not just for one headset, but for all the headsets available and maybe for future headsets that are coming out, we have some problems here right now, because if we only build, for example, an application for SteamVR, we are only able to target this kind of headset, and we don't want that. Right now, thankfully, the SteamVR OpenVR SDK does support both Oculus and the HTC Vive, also the Windows mixed reality headsets. But in general, it's really difficult. For example, if you want to build an app for the Oculus Store, you have to use the Oculus SDK, and right now Oculus doesn't want you to use OpenVR, and how do we deal with that problem is really challenging right now. Essentially, you do have to build an application for each of the platform, and that is really not the best solution right now. And hopefully in the future there will be open standards which will regulate and make it much more easy to build one API and support all of the headsets, and that is still something that is not implemented right now. We will have to use the Unity native implementation, which is what I've chosen for this project, which basically means Unity will take care of this, and you have some abstraction layer on top of the SDKs. You have a guarantee that it will run on most current headsets, and also according to a Unity website, there are some performance optimizations that Unity uses if you use the native Unity implementation. So that is the reason for me to go ahead and not download these SDKs and use the Unity native implementation. So after we have selected our XR settings, I'm going to now also add the Oculus SDK and put it at the top, which essentially means it will first look for an Oculus headset, and if the Oculus headset is available, it will use the Oculus SDK runtime. Otherwise, it will run OpenVR, which is the Windows mixed reality headsets, or the HTC Vive. A big advantage of doing that is if someone has an Oculus headset, it will use the Oculus SDK, which is a bit more stable for the Oculus HMDs. And also, if there is no such thing, it will use the SteamVR or OpenVR SDK for the other headsets. Okay, so now let's get back to the project we created last time. We did create some objects, and there are some windows and views inside of the Unity interface. Let me now a bit explain more what these are. On the left side, you have the hierarchy. The hierarchy is basically showing all of your objects that you do have inside of your scene. So for example, we have our camera. The camera is basically what you will see in the game or in the headset. It is like a virtual camera that are your eyes inside of virtual reality. And if we do select the main camera on the left side, we can see on the right side our inspector has changed. Now we have some properties or components, as they are called in Unity. And these components are describing the attributes of the object. For example, here we have one component which is the transform. The transform is responsible for the position, the rotation, and the scale of the object. And we can now, for example, change that, like, let's say on the y-axis, we want to have a position of 4. Then our camera will be 4 meters high, or we can change it back to 1. And this kind of position here is what is getting updated by the Oculus or the OpenVR SDK. They do send you the position of the headset, or more precisely, the orientation of the headset, and will update these components if you put on your headset. And that is all done in the background by the SDKs we have used. One side note here, though, is this will only be true for the native implementation inside of Unity. If you do download some of the SDKs from the manufacturer website, this transform and position and rotation will not be automatically updated. You will have to do some additional programming and configuration. So the next object on the left, if we go into the hierarchy and select, the next object is our directional light. Here we can modify the scene light, and if I press F, I will see the light in front of me, and its position is not really important because it's a directional light, which means it's the sun essentially, and the sun does not have like a position in that sense. It's basically infinitely far away, and you can, if you select the light, you see on the right side we have different properties now. We can, for example, under light component, you can select color and change, for example, the color of the sunlight. I will leave it right now there on a kind of yellow tone. The next object we created last time is the floor. In our hierarchy, we select it, and we will see that there are different kind of properties. there is like a mesh filter component, a mesh collider, and a mesh renderer. The mesh filter is responsible for having a reference to our 3D object geometry, which is like the vertices and all the data that make up the 3D object, which for us is now only a plane. But if you go into a 3D modeling program, you would see the mesh you have created there, which is like the 3D geometry. Essentially, this is just the data of the object. The next is the mesh collider. The mesh collider, we do have to have one on our floor. If we don't have one, our objects will fall through the floor and there will be no collision. And the final component is the mesh renderer. The mesh renderer does what it says. It renders or draws. It's essentially the same meaning. It draws our object on the screen. For example, if we click on this thing and we disable it, our object or our floor will disappear, which means it will not get drawn. The last thing, if you look at this, you see down here is like a material. We have last time gave our material a green color for the floor, and it will also be visible inside of the mesh renderer. If we go here and look at materials, we see we have one material attached to the renderer, which is our floor material. A material is essentially what it says. It defines the properties of the surface, how rough it is, what color does it have, and all these settings you can define here. So if we do click on the floor material here in the mesh renderer, we will actually get notified that on the left here is our material. And this is what we have created last time. Here in the project window, we created these two materials, and they are what we can define of different kinds of materials. The project window is basically just a representation of our folder structure. And if you go right click on it and go to Show in Explorer, we will see the folder structure in there. So the next object we created was a cube again. The cube is something we can pick up, and it does contain all the same kind of properties on the right. We have a box collider this time because it's a box and not a mesh. A mesh collider is just a collider that is made out of the 3D mesh you have created. And a box collider is like a simple primitive object inside of Unity you can add to your simple objects. Usually it's better to use a box collider instead of a mesh collider in terms of performance. So the collider itself should or does not have to be the same kind of shape that your 3D object has. Another thing in the inspector we are seeing is the tag up on the top. We gave it a new tag last time, which is grab. But first we created this tag under add tag, and then we assigned it. So our script, our grabbing script that we will create, that we have created last time, knows that this object is grabbable. The final two objects we did create last time are the left hand and the right hand. It does have the same components as the other meshes. It does have a mesh filter and a mesh renderer, but it does not have a collider because we don't want the hands to collide. And also we have our hand grabbing script, which is giving us our ability to grab the objects and throw them. The script itself, we also have here in our project window. We have imported it last time. I did provide a link in the description, but also you can check out the GitHub page and there will be the current version of the script. We basically last time imported the script and then we dragged it onto our left and right hand objects. But for our hand grabbing script to work, we also had to configure our input settings. So last time we went to Edit, Project Settings and Input. And in the Input Manager on the right, we did create two new items, which is the trigger left and the trigger right. And we set the axis and the type. And these settings, you can find them out if you look into the Unity manual. So if you want to, for example, have other buttons of your input controllers, you can define them here, and later inside of your script you can access them and really make different kinds of functions you want to have in your VR game. We are basically going to do that in the future, but for now this is totally sufficient. We can grab an object and we can release it and throw it. So finally, we want to talk about fixing some of the stuff we did last time. Some things don't really work as they should. So if we change our cube and its scale of x to 0.2 and the y to 0.05, we have what is essentially kind of a brick. And if we start now our game and we grab this brick, we will see that the rotation is not really working, it's not updating correctly. And also if we sometimes throw the brick, it falls through the floor. So in order to fix our object from falling through the floor, we have to change one line. We have to actually add one line in our script, which changes the collision detection mode from discrete to continuous. And this means that now the calculations of the collisions are much more precise, and objects falling through the floor should not happen anymore. But it also means there's a bit more of an impact on our CPU calculations, and we have to make sure that we don't overdo this. But for now it's okay, and it fixes our problem. The next thing we want to fix is updating the rotation correctly. And to do that, we also have to change our script. Before, if we grab an object and we have it in our hands, our script automatically sets the position of the object according to the position of the hand. But now we should do it different. We are going to parent this object, or rather we are going to parent the grabbed object to our hand, and therefore it automatically updates the transform position and the rotation. If we now start our thing with our updated script, we will see that it does work. The object does really rotate according to our hand, but the other problem is the position. So for example, if you imagine we have a hand, we have to set our object accordingly so it is really in the right position that it should be. That is right now not the case. We will have to add a function in the future that per object it tells the hand more or less on which kind of position it should snap into, and that is another thing we will do in the future. Okay, that's it already for this tutorial. I hope you enjoyed it. If you did, please subscribe to this channel or leave a like. And I'm planning to do much more tutorials in the future. This will be a whole tutorial series on how to create a VR game from scratch. And yeah, also check out my other videos. I'm currently developing a VR game, and there's also lots of updates on there, and also some tips and problems I'm struggling with, and expect to come more from those kind of videos too in the future. And yeah, thank you for watching and see you next time. Bye bye.